Hello and welcome to this video on percent yield. So percent yield is an interesting calculation that we use in order to determine the accuracy of our lab data. And so if we have a known standard or a known value, we can actually measure all of our data, and we can kind of compare it to what the known value is. And so we have this equation, and our equation, percent yield, is equal to the actual yield divided by the theoretical yield times 100. Okay. And so that's the equation that we use, and so we need to define a little bit of what these terms mean. And so the theoretical yield is the stoichiometric calculation value of what we would expect to get from the lab. And then the actual yield is the amount of products that we actually are able to recover in lab. And so I think of the actual yield as our experimental, okay? So experimental. Especially when we are doing lab work, that's kind of the term that I think is a little bit easier to understand. So let's go ahead and take a look at how we would evaluate our percent yield. So the first thing that we have to determine is our theoretical yield. Okay, so that's the first thing. It's using stoichiometry. And so in this particular situation, it's going to ask us what is the theoretical yield. Okay, so we want to know theoretical theoretical yield of Na2CO3, okay, sodium carbonate. If we start with 10 grams of NaHCO3, and so we heat this and we end up producing some carbon dioxide and some water and end up with a result. So let's go ahead and start with those 10 grams. 10 grams NaHCO3. Okay, and I did the molar masses already, as usual. So 84 grams of NaHCO3 for every 1 mole. Okay. Our mole ratios. So we have 2 moles to 1 mole. So we have to make sure that we don't mix these up because they're very similar compounds. So we're going to have 2 moles NaHCO3 for every 1 mole of Na2CO3. Okay. And then finally, our last step, we need to go ahead and determine our molar mass step for our product. And in that case, it is 107 grams per mole is the molar mass. So for every 1 mole of Na2CO3, there are 107 grams. A lot of writing for those ones. Okay, so I did the calculation already, and I ended up getting 6.37 grams of that product. Na2CO3, sodium carbonate. Okay. This is our theoretical yield. Okay, so we're going to use this in the next step in order to determine the percent yield. So in the lab situation, okay, and this is what we need a little more data. We need to know how much was recovered in the lab. So we're starting with the same base that we had, that 10 grams of sodium hydrogen carbonate. And now we want to know if we actually only recovered 5.67 grams. Okay, so remember that the theoretical from the last slide that we calculated was 6.37. And what we have here is this one is the actual, okay, or the experimental. Okay. So actual. So let's go ahead and plug this into our equation. So percent yield. Okay. And we're going to do the actual. So the actual should always be a smaller number. Now, theoretically it should be. That's a terrible way to use that word right now. But if we're actually doing this in lab, we may see that it could be over for a variety of reasons. So on paper, it's usually the lesser amount, but in lab, I've seen it be the greater amount just based on, hey, things didn't evaporate off all the way, or different different reasons like that. So in this case, we're going to put the 5.67 grams on the top and the 6.37 grams on the bottom. So grams are going to cancel, and then we're going to multiply that by 100. And I just went ahead and rounded to the whole number. That gives me 89% yield. Okay, closer to 100% is the best. So closest to 100% is the best results. And so we use this in a lab situation and sometimes have to evaluate on paper as well. I hope that was helpful for you, and we'll practice more in class.